Guest. It gives me immense pleasure to extend a warm and heartfelt welcome to our esteemed guest, Dr. S. Muralidharan, Senior Professor in the Department of Electrical and Electronics Engineering at MEPCO Schlenk Engineering College. Dr. Muralidharan is a distinguished academician with a career spanning over 31 years in teaching, research, and academic leadership. His areas of expertise include power systems and renewable energy, where he has contributed significantly to both theoretical advancement and practical applications. His commitment to research is evident in his impressive portfolio of 61 publications in highly reputed international journals, 45 presentations at national and international conferences. He holds 3 patents. He has also published 12 books. Dr. Muralidharan has also guided several doctoral candidates, nurturing new generation of engineers and researchers. His leadership and mentorship have profoundly impacted the academic and professional growth of countless students. Apart from his academic contribution, Sir's involvement in various professional bodies, seminars, workshops further reflects his passion for empowering others and advancing the field of electrical engineering. Today, we are fortunate to have Dr. Muralidharan Sir with us, and we eagerly look forward to his valuable insights and expertise. Let us all join together in extending our warmest welcome to Dr. S. Muralidharan, and we sincerely thank him for gracing this occasion with his presence. Thank you. Sir, please, sir.
Thank you. Am I audible?
Yes, sir. Yes.
Clear, sir. Yes. Yes.
Let me share my presentation. Is the presentation visible to you now?
Yeah, visible, sir. Yes, sir. Visible.
Visible, sir.
Thank you, sir.
Okay, thank you for your nice introduction. By God's grace, everything is going well. He is the only person who is doing something and making some contribution in this society, in this technological society. And my topic is smart cyber physical system for multi-source vehicle. And this is a very common scenario that you would have gone through when you go through the newspapers. This is a very common scenario stating that New Delhi scenario is like this. More pollution and odd even regulations are being followed in the Delhi and like that. Have you seen this picture? In this picture, most of the vehicles, if I take around 50 vehicles, among the 50 vehicles, around 90% are passenger vehicles, and the percentage of vehicles that is also growing day by day. And every year, every car company are saying that our sales has gone up by this much percentage. Not only the car, but also the two-wheelers. But all these car and two-wheelers, they are working with internal combustion engines. Obviously, either they use the diesel or petrol, whatever be the depending upon the engine. But this is the scenario where what we are facing on day-to-day life. And as far as the pollution that are being released to the environment, you can see the curve that is showing you how the carbon emission is being released to the environment. Thanks to our renewable energy development, we have started using many renewable energy sources, because of which the power developed by the power, that is the electrical power development, has increased, and at the same time the carbon dioxide and carbon monoxide emission has come down. But unfortunately, that emission that is due to transportation, it is also increasing. You can see it in the graph. So this is the pollution level, and this is the these are some of the major pollutants that are being released. And this photograph also showing you how the Delhi is facing. It is not only the Delhi, the other cities are also facing this kind of scenario, because you can see the one which clear picture, the other one with after, and because of the pollution and particulate matters that are being released. So the visibility has come down. And this is the statistics given by IIT Kanpur, especially related to the Delhi alone. And in Delhi alone, they are releasing around the carbon 217.7 tons per day. Carbon monoxide is being released. That is especially at this study is not taken in the whole country. It is a study taken by IIT Kanpur only at Delhi alone. So this is this much amount of carbon is being released into the environment. So in order to control all these things, the government is taking all the steps, and not only our government, the entire world is taking some steps, due to which there are many standards that are coming out. And this is the European standard, Euro standard, that is a very famous standard, Euro standard for passenger vehicles. Even though it was introduced in the year 1992, and started implementing it from 93 onwards. Now we are in 6E standard, Euro 6E standard, that is being followed in majority of the countries. And there may be some change, there may not be some changes in the numerical values that are being mentioned here. In those cases, there are some safety aspects are being introduced. So that is why the numerical value alone I have listed here. Apart from this, there are many safety aspects that are being considered in this standard. So that has not been included in this slide. So every country is doing something. They are taking some steps to control this emission. And as far as India is concerned, even though we have opened our eyes in late 2000 only, but we are trying to catch up with the other countries. This a chart shows how this European standard has evolved. So from 93 onwards, now we are following the 6E standard. But in India, only in the major cities, we have started introducing this BS1, BS2, BS3 standards late 2000. And after that, they have nationwide, this standard has been introduced. Now we have started introducing BS6 standard. Already BS5 standard is already there in the market. And we have started from 2024 onwards, we have started introducing BS6 standard. So what is this standard? This standard is to say that your emission, what you are emitting into the environment, that has to be controlled. So that is a restriction that is being put up over the vehicles. This is not only for our country. These are some of the other countries. In other countries also trying to follow this. United States is having its own standard. Canada is having its own standard, following the US standard. Japan is having its own standard. And European Union and some of the other countries are also following the European Union standards. And India is having its own standard that is already for stage 6 is rolled out. And China has its own standard. Many countries started implementing the curbs, that is the emission norms are being released. Even though these emission norms are being released, the internal combustion engines are not that much efficient to convert the input into useful output. Can anyone say any hint about, any guesses about what is the thermal efficiency of an internal combustion engine? What is the thermal efficiency? I mean thermal efficiency in the sense it's the input given in the form of heat and the output that is a useful output that is being generated. Any guesses? Any numbers? No.
30%.
No. As far as the internal combustion engines are concerned, it's a poor thermal efficient machines, and hardly it may produce 30%. 30% is at the maximum 30% thermal efficiency. Then you just think of what happened to the remaining 70%. It is being wasted. That is why when you ride a mission, when you ride a internal combustion engine vehicle, either two-wheeler or four-wheeler, after a few kilometers, when you stop and you touch the engine, it is heated. It has its own heat generation. So that is why we have the radiators and cooling fins, etc., etc., etc. So even though the internal combustion is the well-known technology that is being developed, it is running the entire world, we cannot increase the thermal efficiency of the engines to some extent, beyond a certain extent. So what is the alternate solution? So the solution is always known to every one of us. This is the alternate option, that is a electricity-based machines. That is the vehicles. Actually, these electricity-based vehicles, so there are many types. Even though we are commonly called as e-vehicle, it has its own type. And compared to the internal combustion engines, the number of components has come down as far as the electric vehicles are concerned. So this right side one is the electric vehicle, and this left side one is this left side one, this is the electric vehicle, and this is the internal combustion engine, where you can see thousands of components in the front bonnet, the engine cabin. So there are thousands of components, starting from the belt, etc., bolt and nut, etc. Everything is there. Because we need more cooling systems, we need cooling for the engine and lubrications, etc. All those things should be there in the front engine compartments. But as far as the electric vehicles are concerned, it has only very few components are there, because mainly it requires a battery, or otherwise any energy storage or any power delivering device, and then a motor which drives the vehicle. So these are the only two major components that are required. Apart from that, there may be some power converters, and there may be some controllers which helps us to drive the vehicle. So this is a very entire scenario has changed, and the number of components has come down. That is why if you see the electric vehicle, the majority of the engine compartment will be empty. Even that could be used for a storage. And as far as the electric vehicles are, as I mentioned, the electric vehicles are concerned, even though we are commonly calling it as electric vehicle, it has its own type. The very commonly known one is the battery-based electric vehicle. So where the battery can be charged from the external source, and then it may help you to run the electric motor, which is driving the wheels. So that is a battery-based electric vehicle. And the next one is a plug-in hybrid electric vehicle, which is a second type, where the oil as well as electricity both can be given as an input. And the hybrid electric vehicle, the input is only the oil. Even though it is a hybrid electric vehicle, input is only the oil. The fourth one is the hydrogen-based electric vehicle. And the last chance is, that is, in order to overcome the issues that prevails in the other electric vehicles, we could combine all the things so that I can extend the range. So let me give you a brief intro about this battery-based electric vehicle and other vehicles. So as I mentioned, this battery-based electric vehicle has a battery in its as a prime power source, usually lithium-based batteries, because lithium-ion or lithium polymer, so any lithium-based batteries. But it requires a charging, frequent charging is required for these battery-based electric vehicles. As far as the plug-in electric vehicles are concerned, as I mentioned, it can be plugged in as well as it can be filled with petrol or diesel. So you have a tank for petrol or diesel, and you have a battery for charging. So both are available. And how it could be done? So if I want to extend my range, because it has the battery-based electric vehicle has its own limitation, that the range cannot be extended. So I needed to search for a charging station somewhere in the nearby area, so that I can charge my battery before continuing my journey. But in the case of plug-in electric hybrid electric vehicles, I can switch over from one source to another source. Or for example, I can go up to 100 kilometers. I can travel by battery. In case if my battery drains down, then I can switch over to petrol or diesel. So which could be refilled at anywhere. So I can switch over to petrol or diesel, and I can use the IC engine. Only thing is, my drivetrain should be capable of getting the power from both the devices, both from IC engines as well as from the electric motor. So a little bit complicated drive system is required in this case. And this is a plug-in hybrid electric vehicle where, as I mentioned, the fuel tank is there and battery is there. And so both will be coupled to the transmission system. So the combustion engine as well as the motor is connected to the driving system, so that which drives the wheel. The next one, that is hybrid electric vehicles, a little bit different, because in this case I could plug in as well as I can. That is, the charging socket is available as well as the fuel tank can be refilled. But in this case, only the fuel tank alone can be refilled. That means what's the usage of this battery? The battery is recharged, or otherwise, when I use the IC engines, the regenerative braking can drive the can recharge the battery, and then battery can be used for electric motors. So there is no external charging provision, but at the same time, the best available replacements, that is oil, that is the only source here that is available here. So that, because currently we have more number of oil filling gas stations, so that is the reason they have started using this one. So this is a hybrid electric vehicles. So as I said, this is the same, a bigger picture of the same. So fuel tank is there, and we have the battery, and we have the combustion engine, and it is running a electric motor. This drives us. It can be a regenerative also. Both it can act as a motor as well as a generator. So when the combustion engine is being used, I can recharge my battery, and whenever I need to switch over, I can switch off this fossil fuel, and I can run from the battery. So this is a hybrid electric vehicle. And the next one is the fuel cell based. So in the previous lecture, sir, the expert has mentioned the fuel cell is a very good alternative. Yes, of course, this is a very good alternative, because the major sizable part of the mass that is for the electric vehicle is the batteries. Even though we are saying that it's a electric vehicle is emission free, we have the battery, so which requires more amount of the manufacturing of battery requires more amount of chemicals that are being used. So this is entirely a different scenario where I am using a fuel cell. The fuel cell is I will tell about what is this fuel cell and how it works. And in this fuel cell, therefore, the perform for the generation of power from the fuel cell, I need the hydrogen. So what I can another advantage is, just like refilling the petrol and diesel, I can refill the hydrogen within few minutes or few seconds or few minutes. Not like battery-based electric vehicles, which require more amount of time for recharging it. So I can easily refill this hydrogen, and this particular hydrogen, and along with the oxygen that is available in the air, that could be used for as a fuel for this fuel cell, and which drives the electric motor. And then if required, I can recharge, or I can charge my battery also for a backup. So this is a fuel cell based electric vehicle. Yes, this is a storage tank, and I have the electric engine, that is a motor that is driving the wheels, and I have the battery also here. So the fuel cell will generate the power. So I have the fuel, that is the refilling provision is there. So the tank will supply the fuel cell to the hydrogen to the fuel cell, and it will generate the electricity. That electricity is being used in the electric engines. So the last one is the multi-power source. So what is the advantage of having a multi-source electric vehicle? Because in this case, I have used another third type, apart from the fuel cell and battery. I have used a third type, that is a different one, not the IC engine, but it is a supercapacitor based. So we know that there are some issues with battery based vehicles. So in the previous lecture, there was a question. So what is the solution for the preventing fire accidents in the electric vehicles? So main cause is the battery. And what is the issue with the fuel cell? Then fuel cell is not that much dynamic. It's like I can say it's like a person who can able to run in a marathon. A person who can able to run in a marathon cannot win in a 100-meter dash because he is sustainable for long hours of running. But if you ask Usain Bolt, who is a master in 100-meter dash, he cannot run a marathon. So both are contradictory in nature. So a marathon winner cannot be a 100-meter winner, but a 100-meter winner cannot be a marathon winner. So I needed to balance both the things. So my supercapacitor is like a 100-meter winner, but fuel cell is a marathon race winner. So I'm going to combine these two fuels power sources along with my battery, which is already proven technology. So the three things are going to power my electric power motor. So which drives the vehicle. So what is the how this this is a plus and minus of the vehicles. There is a fuel cell based vehicles can go long range, quick refilling is possible, and battery based vehicle has limited range, considerable charging time is required. And supercapacitor, very high rate of charge and discharge. That we will be seeing. We will discuss it in after few slides. So it has a very high rate of charge and discharge. Just like as I that's why I mentioned it's like a 100-meter dash. I can in a fraction of a second I can cope up my speed and I can go faster and I can stop. So that is a very high rate of charging and discharging is possible, and little degradation is there. So these are the three things. But this is the gasoline is a very nowadays we are going to replace it because most of the fuels are imported fuel and the emission is also persisting. So this is a scenario. So I'm going to say how these three fuel power sources are being used in the electric vehicles and how I'm going to combine this multiple power sources in a single engine that is for a single vehicle, and how this cyber physical system comes a role in this particular multiple power sources. So first one is the fuel cell based electric vehicle. This is a cross section of the fuel cell based vehicle. You can see as in the previous diagram. So this is there is a high pressure hydrogen tank. There will be a bigger tank, and usually there will be a smaller tank also. So just to have a backup, and there will be a battery system. So yeah, battery system is also there because your vehicle, sometimes when the engine is off, you need to turn on your lights and you need to turn on some of the components that are available in your vehicle. So yes, there will be two types of batteries. One is a high power battery and the other one is a smaller size battery, which is capable of running small devices. And then there is a fuel cell stack, and the fuel cell converter is there, and which runs the motor. So this is the overall scenario of a fuel cell. And this is the block diagram explanation. And a raw fuel, that is hydrogen, is given by a fuel reformer. What is the reason for this fuel reformer is usually the fuel that is the hydrogen may have some moisture in it. So fuel cell is expecting at least 99% pure hydrogen to be given as an input. So for that purpose, this fuel reformer will remove the moistures or anything, so that hydrogen rich gas is given as a fuel for this fuel cell tank. And as far as this fuel cell tank is concerned, it gives electrical power output. It produces electrical power, which is DC power. And this DC power, if required, I can use it directly, or otherwise I can convert it into a AC and I can use it in my system. And apart from this cycle, I have few more cycles here. So one is the thermal management, and there is an air system, and there is a water management. What is this water management deals with? So actually, as I have mentioned, the hydrogen is an input that is coming in. And apart from that, this fuel cell requires another one gas that is nothing but the oxygen. So because we have oxygen in our air, so I can take the air, oxygen from the air, and both this hydrogen and oxygen will release the water. It doesn't mean that it will come like a tap water. Usually it will be in the form of droplets, or otherwise usually in the form of water vapor. So that has to be managed, or how we are going to drain it and how we are going to leave it in the environment. And apart from that, it requires a thermal management because heat is also produced usually. So again, I won't say that it's 100% thermal efficiency. It comparatively it is higher thermal efficiency compared to the IC engines. So the heat that is being generated in the fuel cell, that has to be managed. Some kind of cooling arrangements are required, either in the form of air cooled system or otherwise liquid cooled system, that depending upon the operating temperature. So this is a little bit insight about the electrical part of fuel cell. And so when the fuel cell output is a DC, sometimes I may require a DC-DC converter in order to match the voltage. And then I need I may be having a DC to AC inverter. So for driving my induction motor, usually the induction motors may be the drives, especially the Tesla cars are having the induction motors because of its own advantage. And apart from that, I have the some other, as I mentioned, some supplementary systems are there in the vehicle. So fuel circulating, that is, I need to circulate the hydrogen and I need to circulate the air for cooling. I may need a ventilation inside my cabin, and I may need some headlight and then wiper. All those things are there. So for that, I may require some other DC-DC converter which operates, which supplies these supplementary systems. And apart from this, there may be a battery which can drive my motor in case if my fuel goes off. So that is another one part. And this is a fuel cell based drive system because, as I mentioned, the oxygen is taken from the air and then hydrogen which is stored in the tank that is being taken, and both combined together, and it gives me the electrical power output. In case during the deceleration, my motor can act as a generator, and it can also recharge my battery also. That is also possible in this case. And during sudden acceleration, unfortunately, the fuel cell is not that much dynamic to give fast acceleration, and cannot be done using that much power output cannot be supplied by the fuel cell immediately. So that is the only issue with this fuel cell. Actually, this fuel cell is not a new one. It is there were fuel cell based vehicles even from 1966. Actually, first road vehicle Chevrolet they developed this fuel cell based vehicle and rolled out in the US. And even though this was late 60s, and apart from that, there are some prominent players, current players who are doing this job. There is Yamaha is a fuel cell based motorcycle, and this is a Toyota fuel cell based car buses, and this is a Toyota Mirai, so which is a fuel cell based electric car. And China has also released its own. It has also contributed something in this. This is a China monorail, that is a tram car which is run by hydrogen based. I think you would have gone through some of the newses that come that has recently that is being available in the newspapers. Because the hydrogen based, the Indian Railways started developing its own hydrogen based electric trains. So they are saying that possibly by 2026 they will be testing it. So that is the current scenario in the electric vehicle technology. So the fuel cell is nowadays, because already Indian government has started one mission called as Green Hydrogen Mission. If you visit the renewable energy website, you can see there is a Green Hydrogen Mission. So they have started the mission, and with 2030 as their target, producing the hydrogen both in the form of green hydrogen, that is a natural way, and other ways, and electrolysis way. So whatever the possible ways of producing hydrogen has been explored, and they have started encouraging the hydrogen production. So Green Hydrogen Mission they have started in India. So that is a scenario. So I think is the video visible to everyone?
Yes, sir. Visible, sir. Yes, sir.
Audio is also visible. You can hear the audio, right?
Audio is not.
Introducing Toyota's
It's coming, sir, now.
revolutionary new fuel cell system for the FCV. The FCV's fuel cell generates power, which is created from hydrogen and oxygen. Hydrogen, an alternative fuel for gasoline, is a plentiful, environmentally friendly energy element that is created from a wide range of sources. Hydrogen and oxygen create electricity, which powers the motor without burning hydrogen. The only emission while driving is water, and no carbon dioxide is emitted. The motor provides exceptionally smooth acceleration, making the FCV fun to drive. This is how the electricity is generated. The car takes in oxygen from the air, which meets hydrogen from the high-pressure hydrogen tank in the fuel cell. Many fuel cells combine to form the fuel cell stack. Hydrogen is supplied to the negative anode and activates, releasing the electron. Then the electron flows to the positive cathode to generate the electricity. After releasing the electron, the hydrogen becomes a hydrogen ion, moving to the positive cathode and bonding with the oxygen in the air, forming water. Hydrogen and oxygen come together in the fuel cell stack to supply the electricity to the electric motor via the power control unit.
So that is a Toyota Mirai technology. Not only the Toyota, every fuel cell powered vehicle will use a similar technology. And not only that, already countries have started working on submarines which works with fuel cell based submarines. Why do we need this kind of fuel cell based submarines? Because majority of our submarines are currently running with the diesel. So very few countries are having nuclear powered submarines. That too very the quantity is very small. And majority of the submarines are working with diesel powered. So as we know that when you ignite and when you use the diesel based engines, obviously the emission will be there. So where to store that emission or where to release that emission? If the submarine is inside the water, where to release it? If you start releasing it in the water, what will happen? It will create bubbles. So the bubbles will come out. Once the bubbles has come up to the water surface, automatically the enemies will try to identify you. And also the diesel engines will have more amount of noises. They will produce more noises also. So this is the scenario of the diesel powered submarines. So that is why as far as the submarines are concerned, they used to come to the surface, water surface, even though when they are traveling, they are supposed to go and beneath the water. They used to come to the water surface and release the exhaust gases into the atmosphere and then again go back. Even though the oxygen is being released inside the submarines, the oxygens are released based on the chemical reactions. They will be producing oxygen and they will be using it inside the submarines. But they need to release the exhaust gases into the atmosphere, and that's why once in 2 days or 3 days they needed to come out of the water, and then they should be surfaced and they will release it. But what will happen? Sometimes there may be some restrictions. I may have to be in the water more than a week together or month together. So in that case, it is highly impossible to have a diesel powered vehicles, submarines. But if it is nuclear is the best option, but unfortunately it is a very costly affair as well as the risky affair also. So what they have started doing is they have started working with submarines, working on with fuel cell. India has also started building up its own Kalvari class submarines, which already having the diesel engines, so that they are replacing it. They are slowly replacing it with some fuel cell based power supply. And I think as per the government statistics, by 2030 they will start introducing it in the Indian Navy. So that is the scenario. So that application, as far as the fuel cells are concerned, the applications are very wide. And India is also have another major player in the fuel cell based vehicle is Hyundai. So they have their own vehicle, that is an Nexo, that is a first fuel cell based vehicle which has got the certification, that is the Insurance Institute of for Highway Safety. So that certification they have got. So they are ready to produce the this kind of fuel cell based vehicles in India also. So this is a very basic principle of fuel cell, where the hydrogen is entering and which is split into two. Electrons are being released, and the hydrogen ions, along with in combination with the oxygen, it produces the water vapor. Usually water in the form of vapor used to come because of the heat. So here you can see that there is a membrane that is sitting in between, so which allows only the hydrogen to enter and not allowing the electrons, so that the electrons goes through the external circuit, which is nothing but our electric current. So the electrons are forming the electric current, and this membrane should permit only the hydrogen ions to enter into it. So this is the basic concept of fuel cell. So when I see the basic components inside this, even though that is a very simplified form of representation, so it has many components in it, because I need a membrane which is sitting in between. So this is the in between some membrane, and this on either side of this I needed to pass the gases. So I have the gas diffusion electrodes are there, so which is acting as an anode as well as the cathode, so on either side. And apart from that, I have the flow control plates are also there. So this is a little bit elaborate version of fuel cell. And what is this? The in-between proton exchange membrane. It is, even though it is one of the type I am mentioning, there are many types of fuel cells, and this is a very commonly available, commercially available fuel cells. And this is a proton exchange membrane. That is the membrane which is sitting in between, which is doing the wonder. So actually, this is the in between the membrane. As you can see, there is a part mentioned as A and another part B. So this is a photograph of the proton exchange membrane. Actually, this proton exchange membrane, it seems to like a normal plastic sheet, over which there is a coating on either side. So this is a very common, seems to be a very thin in nature, and in some cases it is about 20 microns in thickness. So that is a very simple, but which makes the wonder. Actually, what is this catalyst? That is the catalyst that is being coated on it. That catalyst is a carbon-based platinum catalyst. It has platinum as well as carbon. Platinum is 10% on a carbon. This is the powder. It's in the form of a powder. So this powder is coated on the layer. So that you would, I think you would have gone through the newspapers. What is the rate of gold? Then just we have not, so far we have not gone through the rate of platinum. Just to think about the platinum rate, which is still costlier than the gold. So actually what we are doing is we are using the platinum or platinum ruthenium alloy that is being used as a catalyst. So the platinum is a little bit, even though it is a 10% in nature, so it is a little bit costlier, which is required here. But still research is going on in order to change because in order to replace it with a less costly device, the catalyst. Okay, I need I have the membrane in between. So on either side of it, I need a gas diffusion layer. So the gas diffusion layer is, so this is the gas diffusion layer, and this is the gas diffusion layer, and this is a, on either side of the membrane, we have the gas diffusion layer. What is this gas diffusion layer? It's a very simple carbon-like, what to say, a sheet of carbon paper. A sheet of, it seems to be a carbon paper, which is partially coated with polytetrafluoroethylene. So on either side, it seems to be, it's a very blackish in color. So it's a microporous. It has microporous holes inside it. So this is helpful for the gases to enter, so that it can. That is, I already told you, that is the catalyst will allow only the hydrogen to permit the hydrogen alone. So I need some small porous material. It's a porous material through which it will enter, and it can go through this membrane, and then it comes out. So it is a gas diffusion layer, so that because we are supplying gases on either side of the membrane. One side it's hydrogen, the other side is oxygen. So this is a single cell, single fuel cell. So where a single cell, and I mean one in between membrane on either side, the diffusion layers are there, the electrodes are there, and the gas supply units are there. So this is a single fuel cell, but this single fuel cell may produce only 0.7 volts, so which may not be sufficient for us to produce to drive anything. So but what I needed to do is I need to, just like a battery stack, I needed to connect more number of fuel cells in series and parallel, so that I can produce a required number of required amount of voltage or current for my system. So in that case, when I start connecting them like this, it may occupy more spaces because this is a single cell. If I go for such cells connected, it occupies more space. So but what I can do is I can in between the cells, you can see in the diagram. So one is an anode, the other side is a cathode. So instead of having two electrodes of this nature, I can replace it with a bipolar plates. So that is a bipolar plate. So for one side, so you can see it here. So this is the bipolar plate that is in sitting in between. Because on one side, I can show you the diagram also. This is the bipolar, actual photograph of the bipolar plate. So you can see there are some grooves on the surface of the bipolar plate through which the gases could be circulated. And over this bipolar, just above this bipolar plate, you have the gas diffusion layer. So which is not permitting all the gases to enter into the membrane. So it is filtering giving some filtering. Then again, membrane is there. Membrane is allowing only the hydrogen ions to enter, remaining being filtered out. So this is a bipolar plate. This is the need for the bipolar plate. So it sits in between, and one side it acts as an anode, and the other side it acts as a cathode. So because on one side you need to circulate the hydrogen, on the other side you need to circulate the oxygen. So it serves as a feeding oxygen to the cathode and fuel gas, that is hydrogen, to the anode. So that is possible only with this bipolar plate. So again, it is made of aluminum, steel, titanium, and nickel. So again, little cost involved is more. And even this next one is the gasket. So what is this gasket? Again, even in our houses, our pressure cooker has some gasket, so that the gas leakage could be avoided. So the same thing here, we have a gasket system, which helps us to control the flow of gases. Leakage of our gases could be avoided. So I have the membrane in between. I have the gas diffusion layers, and also this is a plate over which I am placing the gaskets. So this is a dispersed view of the same. So this is the gas diffusion layer, this is the membrane, and this one is the gas diffusion layer on the other side. And I have the plates on the bipolar plates on either side. So this is a very simple structure for a single cell. So because of the bipolar plates, this can be used for I can extend it for any number of cells. I can extend it for depending upon my required voltage. Okay, the next one is a battery powered electric vehicles. So I think this is a very common, only known technology. Nowadays, majority of our vehicles are running with the batteries alone, the battery packs. But actually, can anyone say when the battery powered vehicles was started rolling? Can anyone say the very first electric vehicle was introduced? That was that ran in the roads of France. Again, I'm giving another clue. It ran in the roads of France. Actually, batteries were introduced in the year 1859. They have invented it. After that, after this, around 1862, if I correctly remember, 1881. In 1881 April, they have used this lead acid based batteries for running the first human carrying electric vehicle on the roads of France. So that was the very first electric vehicle that was introduced. Okay, then what is this battery-based vehicle? So again, I have many types of batteries in that are currently available in the market. So any type of battery could be used. But anyhow, any battery system requires, and even with the fast charger system, I may need around 4 to 8 hours of charging, so that I could be charged and I can extend my range of travel. For example, in case of Tesla Model S, it has about 7,104 cells split into 16 modules with 6 groups of 74 cells each. So that is the volume of battery that is required. So 7,000 cells that are being connected. 7,000 cells are being connected in different parallel series combinations, so that it can produce a required power which can be supplied to the motors. So this is a cross section of a battery powered vehicle where the battery occupies more space. And as I mentioned, the journey started with a lead acid battery. Then later we have switched over to nickel metal hydride. Then we have moved on to lithium ion based batteries. Even though lead acid batteries are being used in the internal combustion engine for the electrical supply, so it's a very bulkier one. It's a bulkier one and it occupies more space. It is heavy. Almost when they started using this lead acid battery, almost 50% of the 25 to 50% of the entire mass is occupied by this batteries alone. So that was the scenario. So even though it is cheaper in rate, it is the weight is a major criteria. So they have started introducing the nickel metal hydride batteries. So with 20% of it has its own disadvantage. About 20% of self-discharge in the first 24 hours itself. Even when you are not using it, 20% self-discharge. Self-discharge means it will start discharging without any usage. It will discharge its power. And afterwards, 10% per month. That is a scenario of the nickel metal hydride. So people started using this lithium-ion batteries. So nowadays we are starting in lithium-based batteries, especially lithium-based batteries. Many varieties are there. But still we are going for a different version. That is sodium-based batteries have started. The research has already started. They have started introducing sodium-based batteries. So because lithium is a very costly metal, that is as far as the today's world is concerned. Because very few countries are having the lithium resource, especially the countries like Bolivia, Chile. They are having the major resource. And it has the expensive metal, so which is available Australia, Canada, US, Bolivia, Chile are the major producer of this. And also this lithium-based battery, even though it was very costlier when it was introduced, you can see it here. 2010, it was about $1,183 per kilowatt hour of lithium-based battery. Now it is almost very cheap comparatively, about $135 per kilowatt hour. So that is the scenario. We still expect that it may go down to $60 per kilowatt hour. So that is the thing. That is the technology is being developed so that I can produce more optimized way of battery production. But this type of battery packing, this lithium-based batteries have come in 3 ways. One is the cylindrical based one. The other one is prismatic based one. So, any queries? Sir, any queries? Can anyone answer?
No, sir. No, sir. 1 minute, sir.
I think the admin can mute him. Okay, let me continue. So different types of battery packings are there. So what we are seeing nowadays in our remotes and other things, they are cylindrical batteries. Nowadays, we have majority of our manufacturing plant are capable of producing only cylindrical based batteries. So majority of our batteries, because already we have this technology for over years. So the majority of the manufacturing plant, it is not easier to change the production process all of a sudden. So majority of our batteries are cylindrical based. So that is why even now these lithium based batteries are also coming in cylindrical form. Apart from that, prismatic batteries. Very common example is our mobile batteries, which is very flat in nature, a rectangular form of battery. And the other one is the pouch based. Pouch means, let me say, an analogy is sachet, shampoo sachet or oil sachet. So like sachet based, that kind of structure. It's a pouch based one. So these are the three categories of three ways in which the batteries are being produced. And these batteries can be, individual cells can be grouped together so that they can produce a module and then a pack assembly. So this is a cylindrical cell, which when they are connected in series and parallel, so it produces a module, and then more such modules are connected together. It produces a battery pack, the entire pack. This is for a prismatic pack, and this is for the pouch based one. And how they are being connected. This is a photograph of how the battery packs are being made. This is one such a battery pack made with cylindrical lithium-ion based batteries. Usually they will be spot welding is being done. Laser based, they are welded together. You can see the buildings are being done. They are connected in series and parallel depending upon the requirement. A complete set of battery here. This one, and this is the spot welding is being done using for producing the battery pack. But this battery packs, there was one question, as I mentioned, why this cars and two-wheelers are getting fire accidents are happening in these vehicles, battery-based vehicles. Because as the expert has mentioned, exactly that is the reason. Because we have more things to be managed in the battery. Number one is voltage. Apart from voltage and current, which are the electrical parameters, we need to maintain the temperature of the battery. That is also very, very important issue. Once you battery management system, what is this battery management system? It is which detects the unsafe condition of the battery. So for that is a system which manages the battery. Very simply saying, it's a system which manages the battery. So because this system has to take care of the especially the voltage, current, and then the temperature of the battery, individual cells. You just think of how many cells are here in this battery. But it is possible nowadays with the electronic development. So individual cells can be fitted with a battery management small system, so that individual cell temperature, individual cell voltage and current can be collected, and that can be given to a processor so that which can make the decisions and they can give. Once if I compromise with that, instead of having a individual cell being monitored, if I start going for a cheaper version of battery pack, then which can measure only the voltage of the entire pack, randomly chosen cell, then obviously there is a possibility that the thermal management is not done there. Even though another advantage of having this kind of cylindrical battery is, when we arrange a battery, cylindrical battery, in the form of 4 cylindrical batteries are being kept. So obviously there will be an in-between gap. So that gap is required for heat reduction, because when the normal operating temperature of your this lithium-based batteries is about 35 degrees. If it goes beyond that, beyond the 35 degrees, then automatically it may gets heated up, which may drain the battery very fastly, and at the same time, for continuous usage, it may result in the fire accidents. So I need a battery management system. So a battery management system is mainly used for thermal management, safety or protection. That is in order to avoid that. And then I can acquire the data, so that data can be used for me to know about what is the status of the battery, because I need the status of the battery. Because even our mobile has its own battery status indication. Your mobile has some indication which is showing you what is the voltage, what is the power that is available, how long you can use it. So that is data acquisition, and I can do the cell balancing. That is another important aspect of the cell balancing. And then battery state estimation. and charging, discharging control. What is this cell balancing? This cell balancing is very, very important. So this is a block diagram showing you what are all the functions that are being done. So what is this cell balancing? So before that, let me tell you a small two terms. That is, one is state of charge estimation and state of health estimation. What is the state of charge and state of health estimation? These two are the very important parameters. Just like what is the state of charge is what is the power that is available. It represents the available capacity with respect to the rated capacity of the battery. And state of health is how long I can use this battery. Because even you wonder, when you use a mobile phone, in the initial periods, even for a small time period of charging, you can maintain the power in your mobile phone for a longer usage. But as the years goes after 3 years or 4 years, so even when you charge it, the charge may not rise, and your battery may show you 100% charged, but unfortunately within a few hours of usage, it may get drained down. So that is the health of the battery has gone down. So useful lifetime of the battery has been consumed, and how much remaining, because every cell has its own charging and charging discharging cycle. So this is the limitation. So that kind of limitation needs to be monitored. So state of charge and state of health, both are being monitored with the help of the voltage and current that is being measured from the battery management system, and that is being estimated, and that estimation is required. Why I'm saying all these things is because when I go for a multiple fuel based system, so obviously I need a forecasting. That forecasting should tell how long I can go with this fuel, and after that how I can switch over to the next fuel cell, next power device. So I need the state of health and state of charge is required. So all these things are done using the battery management system. There are different ways of doing this job. I'm not going into detail about this state of charge estimation. There are some direct methods and there are some indirect methods, especially like open circuit voltage, Coulomb counting. These are very commonly used direct methods. I'm not going in detail about this because time is the constraint. And this is the battery management system architecture. So there are different ways in which how this battery management system can be connected together for a single controller. There is a master control. There will be a master controller. So individual cells has its own small units which measures all these things. So individual cells will have voltage, current sensor, and temperature sensor. All those things will be measured, and all this information will be sent to the master controller, which is the centralized one. So which requires, but unfortunately, this requires more number of ports to be connected. Number of ports, input ports are very high. So that is an issue with this. So that is a master control. The next one is again another way. So all these measurements have to be processed here only. But here the processing will be done in the individual cell wise, and only the communication will be sent to the master controller. And this is another architecture where the modular based architecture where there will be some slaves and there will be some master. So instead of having a centralized master unit, I may be having a master which is getting information only from these slaves, and the slaves will be connected, in turn will be connected to the sensing devices, voltage, current, and temperature sensor devices. So these are some of the BMS architecture. I am not going into it, just I am giving an introduction to this. And this battery management system is also important because of the big cells that are present in the battery pack. So I have mentioned that you may be having more number of cells in the battery pack. So that battery pack may have very small number of weak cells, because even though it is manufactured at high precision, not all the 100% of the cells are having the same characteristic. There may be some small deviation. So because of which one or two cells may be very weak in nature. So unfortunately, what will happen is when I charge this, so the lower capacity cells will charge faster, but at the same time the other cells will not be charged to the maximum level. And similarly when I drain it, the lower capacity cells will drain very faster and it will get emptied, but other cells may be having some small amount of voltage inside, that is power being stored inside it. So this issue can also be, that is called as a balancing of cells. There are two ways of balancing the cells. I am also not going into detail about this balancing. One is called as passive balancing. The other one is the active balancing. Passive balancing is the one where the excess amount of energy, let us say in this case, this battery is having excess amount of energy compared to the other batteries. So this excess amount of energy can be spent in the form of heating resistor. A small resistor could be connected. So the excess amount can be spent. So as a result, all the cells will have the same amount of charging. And that is the passive balancing. That will be easier. But active balancing requires a little bit complicated one, where the surplus energy can be stored in the other cells. For example, these two cells are having excess energy. So this excess energy can be filled in other cells. So that just like pouring the water in one bucket in another in the empty buckets. So just like that, I can do it. So that requires a little bit complicated circuits, and that is also possible with some capacitors and inductors and switches, MOSFET switches. That is also possible. Okay. So balancing is very, very essential. The third source is the supercapacitor powered source. The supercapacitor source is the third source. Why I'm going for this supercapacitor, as I already mentioned, it is a easier way of acceleration, deceleration can be done using the supercapacitor. So what is this supercapacitor? Very normal capacitor has two electrodes in between the charges are being stored. But in the case of supercapacitor, it has higher electric energy density and it has multiple in between layers, so that the more amount of charge can be stored inside this supercapacitor. So this is the diagrammatic representation of supercapacitor. So where you will be having the solid electrodes that are being kept, and there will be separators. These are the separators that are kept on either side. So this is just a simple one. So I can show one is a positive, the other one is a negative. The in between there is a separator. So the separators are there. So multiple capacitors could be arranged. See, this is the equivalent circuit for this arrangement. So where instead of a single capacitor representation, I have multiple layers. So as a result, two capacitors connected in series. So more energy density is available in this case of supercapacitors. There are some supercapacitor banks, just like lithium-ion based batteries. This is also available in the market. This is one such type. Maxwell is one such type of supercapacitor banks. This is a supercapacitor bank. So this is also available in the market. As I have mentioned, this is the charging discharging time that is required. You can see this is the rechargeable battery charging discharging for longer period of time. But as far as the supercapacitor is concerned, charging discharging can be done in a faster sense. There are some vehicles that are running with the supercapacitor. This is the supercapacitor banks that are being kept inside the vehicle. So this is a bus being operated in Shanghai, which is running with the supercapacitor. So I think you can see the bus. It is coming to a stop, and when it stops, the arm rises, and it is charging the supercapacitor in the. You can see it here. It is rising. Within a fraction of a second, it goes up, and before the passengers board and unboard, so before that period, it is getting charged, and as soon as the passenger movement has going down, when it stops, so automatically you can bring it down and you can use the charge, and it can make use of the charge and it can run. So they have lowered it. The vehicle started running. So this is a very fast way of charging, discharging can be done using this supercapacitor. So that is the advantage of this supercapacitor. So supercapacitor has, even though it has an energy density, very small energy density compared to the fuel cell. That's why I compared it with a 100-meter dash and a marathon race winner. So fuel cell are like a marathon race, but supercapacitor are 100-meter dash. So easily they can be charged and they can use for it for acceleration, sudden acceleration, deceleration can be done using this supercapacitor. So when I have all these three sources connected together, that is fuel cell, supercapacitor, battery, all these three things are connected. So through DC-DC converters, it can be connected to a DC link. So if required, I can convert it into AC and I can use it for running my vehicle. So what now? How this fuel cell capacitor? How this can be connected? So usually this fuel cell is not a rechargeable one because it runs with hydrogen-based. It's a hydrogen-based one. So that's why I can have a single direction converter. And apart from this, the battery as well as supercapacitor both can be used as a bidirectional converters can be connected here. So yes, they can be connected to a common bus and which can convert it into AC and it can be given to the traction motor. So when it comes to the traction motor, I need to fix what is the size of the fuel cell, what is the size of the battery, what is the size of the supercapacitor. I'm not going I'm little bit going in a fastest way in to cover this topic, because any vehicle has its own power requirement. There is force required to overcome the friction as well as the air drag as well as the gravitational force. So in this case, I have taken the tractive force as the total force, which includes the rolling force. The rolling force is nothing but the force that is because of the friction that is available in the surface. And the FAD is the force due to air drag. That is when the vehicle moves, what is the force that is being faced by it. And FG is the force due to the gravitational pull. That is because of the weight, its own weight as well as the passenger's weight. And Fi is the initial force. So these are the forces that is required. So there are some formulae, that is standard formulae that is available based on the rolling force, based on the mass of the vehicle, gravitational force, and then rolling coefficient. This rolling coefficient depends upon my surface because some of the vehicles are meant for road traffic, some of the vehicles are meant for hill area based vehicles are there. So the rolling coefficient will vary. And then this the angle, that is the angle, this is the alpha angle. So the gradient that is required. So what kind of vehicle it is, what is the purpose of this vehicle? So that is being controlled by this rolling force. And this is the force due to the air drag, that is because of the air friction. So it includes the air density, coefficient of drag, and front area of the vehicle, and then velocity. What is the maximum velocity that is expected from out of the vehicle? So that is why majority of the vehicles are aerodynamic in nature. So in order to reduce the front area of the vehicle, and then the gravitational force. So the mass as well as the gradient angle plays a major role. And then the inertial force, which includes the mass of the vehicle and the acceleration that is expected. So all these things, all these forces are to be added together so that I can expect what is the tractive force. So once I know the tractive force of this vehicle, if I multiply it with the radius of the vehicle, just like our motor calculations, if I multiply it with the motor radius of the wheel, I can calculate the torque that is required for the wheel to drive. So, but the radius of the wheel is not directly given because radius of the wheel is entirely a different scenario, not like our motor brake drum. So, because when I start using when the vehicle is not filled with passenger, obviously it will be full. When 3 or 4 people enter, with a hefty people are entering into the vehicle and they enter into the vehicle, automatically the radius of the vehicle will come down because air gets pressurized. So as a result, the radius will come down. So I cannot fix a single radius. So I need to find out the radius from the aspect ratio that is given in the vehicle. Usually in any tire, if you go through the tire specifications, there will be 3 parameters that are present. From these 3 parameters, I can calculate. What is this? Actually, this is the 60 is the aspect ratio. This is the aspect ratio. Aspect ratio is nothing but is a ratio between the height and the width. So the height is given, the width is given, the width of the vehicle, that is, this is the width of the tire in mm. That is usually that will be given. So you can see it here, 255 mm. So that is the width of the vehicle. So this width, from the width and from the aspect ratio, I can find out what is the higher h, that is a high wall height. That is a wall height in the sense this is h. So this h is visible. This h is can be calculated. Once this H is calculated, this H is not sufficient because this is one H and this is the other side of the vehicle is also the diameter is also the diametrically opposite. So this is a H and this is another H. So 2H. So in order to find out the wheel diameter, that is I need to find the wheel diameter, I need the T is the rim diameter. That is, this is a rim. So usually nowadays modern rims are there, so with the various diameters. So that rim diameter plus this H and as well as this H, that is the total DW, that is wheel diameter. From this I can calculate the radius. So as I mentioned, this radius is not the original radius because when few people get into the vehicle, automatically the air gets compressed. So a compression coefficient, I have used a 0.95. So it has got compressed to 95%. So 95 into DW divided by 2 is the radius of this. So when I multiply this radius with the force that is required, then I will get the torque. So once the torque on the wheel is, now what I have calculated is the torque on the wheel. So the torque on the wheel is not sufficient because I need the torque of the motor. So torque on the wheel divided by the gear ratio, because we may be having a, whether it is an automatic or otherwise manual gear. So the gear ratio, when it is divided by gear ratio, you will be getting the torque of the motor. So from the torque of the motor, that is, and also another parameter is RPM. How fast it has to be, it has to rotate. Because majority of nowadays, if you see the majority of our dashboards, you will be having both RPM counter as well as the speed counters. So RPM is another important parameter because vehicle speed requirement is required. So one vehicle may be designed for 100 kilometers, and the other maybe if it is a Formula 1 race, then automatically it will be designed for higher speed ranges. So vehicle speed requirements divided by the circumference of the vehicle, the wheel will get you the RPM of the wheel. So from the RPM, wheel RPM, if you multiply it by gear ratio, then you will get the RPM of the motor. So now I know the torque of the motor and I know the RPM of the motor. I can calculate the power requirements. Once I calculate the power requirement of the motor, then I can calculate the controller current rating. So because I know what is the power rating of the motor, so how much power, peak power is required. So from that I can calculate what is the efficiency. So from the efficiency I can calculate what is the current requirement, DC current requirement. So usually this battery, usually the four-wheelers are running with the gears. Some of the, if you take the two-wheeler, usually they will be running with the hub motor. So hub motor, there it will not come into the picture. Directly it is being connected to the wheel. So there, this picture, this gear ratio will not come into the picture. And then as far as the battery's capacity is concerned, so what is the mileage requirement? Because each device, each vehicle is designed for one specific range. So my mileage requirement is 300 kilometers. Then what is the average speed requirement? What is the current consumption? So from this I can calculate the battery capacity. So my battery capacity will help me to identify what is how many number of cells are to be connected in series and parallel, and how they are to be how they are going to supply. The next one is a fuel cell. So once this is very similar to this battery capacity, the fuel cell voltage and the power rating is depend upon the power rating of the motor, the peak power rating of the motor. As far as the supercapacitor is concerned, as I have mentioned, the supercapacitors are mainly used for acceleration, deceleration in this case. So how much time I need the backup, the acceleration, because the fuel cell may not be sufficient, they are not that much dynamic. So I need some backup. That backup is given by the supercapacitor. So how much time it is in terms of seconds, if it is maybe 60 seconds or 30 seconds or 40 seconds, the time required. And also what is the current rating, how much current is required, because I know what is the capacity of my motor. So from that, what is the current that has to be supplied? So what is the voltage charging and discharging range, maximum voltage and minimum voltage of the capacitor. So from this I can calculate the C, that is the capacitor rating. C can be calculated. So because I need, if I require more amount of time as well as more amount of current is required, then my C has to be more. So from the available supercapacitor in the market, how many number of capacitors are to be connected in series and parallel, that calculations can be easily done. So once all this can be done, then comes the wing of AI, that is the cyber physical system. So this cyber physical system, what it is doing, what is this cyber physical system? Even though it was this word was coined in 70s while the microprocessor or microcontroller are introduced. Nowadays, this cyber physical system has gathered a momentum. Actually, it includes both physical components as well as the cyber system. Both from the name itself, it has both physical system as well as the cyber system. Cyber system means it includes network, it includes the computation, it includes the storage, all these things. And apart from that, physical system includes, the physical system is nothing but the sensors and whatever the monitoring devices that we have. So it includes the sensors and actuators. As far as the vehicles are concerned, some kind of actuators, because you are pressing the accelerators, and how it has to be actuated. In case if it is autonomous vehicles, the actuators has to be done by themselves. So because the cyber physical system mainly intended to go for autonomous vehicles, so the sensors will be there and the actuators will be there, and the humans just to watch what is happening, just to monitor. And then the controllers are there, and then network is there, and if required, some data can be stored, and the data can be retrieved from the network. So actually, there are three layers of thing. So one is, as I mentioned, the sensor layer. The other one is the communication layer. The other one is the computational layer. That is the industrial application layer, where the computation is being done. So the physical components, and then the detection components, and then the control and communication components, all the three components are present in the cyber physical system. You may be asking why this is important, why this cyber physical system, why don't I go for an embedded controller which can do it? So even though the embedded controller are cost constrained, have cost constraints, so they are available cheaper in nature, but the computational capacity may not be sufficient, because whatever the job that is being done here it's a real-time job. Because when you go for an autonomous vehicles, automatically your braking should be very fast in case if somebody crosses you. So braking, because we know about the road condition of our road conditions. So when my operating system should be faster enough so that it can make the decision. It has to apply the brake and it has to stop. So that kind of real-time operating system cannot be implemented with the normal Arduino or otherwise any normal embedded controller, but it may be cheaper. But this real-time systems are required, real-time fault tolerance systems. It should be very fault resistance. The tolerance should be very high, because I cannot take chances. And also I have the wireless system. The wireless cannot be done. So the wireless, instead of wireless, I can go for wired also. And also I need a linear adaptive distributor system can be connected. So all these things could be put together. But at the same time, when you go for this kind of scenario, so it is a interdisciplinary boundaries. It crosses the boundaries. So as a result, because it requires a software, it requires a control system, it requires the sensors to be integrated. So a little bit a cumbersome process. That is why still it is in the research in research to implement all these things in the real-time scenario. So in what way this cyber physical system can help you is it can help the advanced driver assistance system. So to make you comfortable, and it can help you to give a safety and security, and a battery management system can also be taken care by this. And also the state-of-art infotainment. The state-of-art infotainment includes contacting through mobile phone using Bluetooth, and as well as loading the Google Map and identifying the next charging stations, or everything can be done using this infotainment. So all these things can be done using this implemented using this electric vehicle, using the cyber physical system, which is also connected to the cyber system. Why it is actually connected to the cyber system is because let me skip this one. Because I'll come back to this. Because my intended purpose of cyber physical system with the 3 power sources is I have to how long I can travel. I needed to extend my traveling range. The traveling range in the sense how long I can go with this battery, how long I have to switch over to fuel cell, how long after how, when I needed to switch over to supercapacitor, when I needed to charge it back. So this is a sample algorithm that I'm giving you. So I need, even the autonomous vehicle can select their own routes, the traffic jam, where is the, because I can load the road conditions either with the some any of these softwares like Google Map or Logi Road L2R. So any software can be integrated with this, and I can map my trajectory in what way I can go to my destination. So, and I can collect the data from the sensors, from voltage, current, and hydrogen fuel sensors can give the input, so that how, in what way, because because of the traffic jam, if I have to reroute my path, then will it be possible with this fuel? Will it be possible to reach the destination? So that decision can be done. So the strategy that has to be, what is the vehicle load, what is the speed at which it has to be done, and what is the acceleration required, and what is the state of charge, what is the state of health. All those things are to be used, and my cloud can also be used, because when I travel in the same route in the next time, the same information can be retrieved back, and I can use it. So this is a sample driving cycle. So this is a sample driving cycle where, as I mentioned, supercapacitor can be used for acceleration, and then the battery will take over. And then once the battery, when it starts decelerating, automatically the regenerative braking can be applied, and it can recharge the battery as well as supercapacitor. And then again battery or fuel cell, again battery or fuel cell. So this cycle could be decided. This cycle can be cycle. As a human, we are not in a position to decide all these cycles, because of based on majority of the parameters, each and every parameter. Then your dashboard will be filled with parameters and lights. So you need to take. You will be, instead of driving the vehicle, you will be in a position to monitor the sensors. So all these things can be taken care by the cyber physical system. So possibility of I have given listed some of the possibilities how it can be done. So how the battery can be, when the possible power exchanges can be done with high battery as well as low battery, because high battery is for driving the vehicle and low battery is for supplying for the auxiliary units. So this is a way in which the cyber physical system can be implemented. I think I'm exceeding the time. Is it Mr. Venkatesh, Dr. Venkatesh, is it time?
Yes, sir. It's a feedback session.
Okay. Then let me
It'll take 2 or 3 minutes, sir.
with this few words. This is the future in the hands of electric vehicles that everyone will accept it. And the reliability can be increased. Reliability as well as the range can be extended using the multi-source electric vehicle, where your computational requirement will also increase, which can be implemented using the cyber physical system. And then especially the power management can be done using this. Power management can be easily done using this cyber physical system, so that we can operate the vehicles more efficiently and optimally. I can do it. And also the cloud can also be integrated, so that the rerouting of vehicle can also be done easily. And I can pre-plan my traffic, and I can, based on the traffic, I can pre-plan my route. And if required, I can use the same route for my next travel also. So all these provisions can be implemented using the cyber physical system. These are some of the references that I have used. I think let me close this session by saying thank you. Thank you for all the participants, as well as the SRM Madurai, as well as the faculty, Venkatesh and Dharera sir, for giving me an opportunity to share my thoughts about this cyber physical system, as well as the multi-source energy system for electric vehicle. If I am ready to answer any of the queries.
Participants can post their queries in chat box, or you can unmute your mic and ask questions.
Thank you. Let me, I have been given an opportunity. I don't know how much I could be able to give information about this new technology. But to some extent, I think if some of you have got overall view about this physical system and other other power sources that are being used in the electric vehicle, then I will be very happy.
Hello, madam.
Sir, okay, sir, let us proceed.
You can close it. Yes.
Sir, on behalf of everyone, I would like to express our sincere gratitude to Dr. S. Muralidharan for his enlightening session on a smart cyber physical multi-source energy system for electrical vehicles. Sir, your presentation provided us with a remarkable understanding of how cyber physical system can revolutionize energy management in electric vehicles. The way you address the challenges and practical implications of this advanced technology has broadened our knowledge and inspired us to think critically about its future applications. Sir, and one more thing, your use of pictorial representations and visuals made complex concepts incredibly easy to understand and grasp. That was very nice, sir. The clarity and simplicity of your approach allowed us to follow along seamlessly and engage with the subject matter more effectively. We truly appreciate the effort you put into delivering such a well-structured and visually appealing presentation, sir. Thank you for sharing your expertise and offering such a compelling and forward-thinking perspective. It was an absolute privilege to learn from you today, sir. Thank you, sir.
Thank you. Thank you. Thank you for giving me an opportunity. Thank you.
Madam, sir, thank you very much, sir. Murali, sir.
Thank you, sir.
Nice presentation, sir.
Thank
Thank you.
Thanks. Thanks a lot.
Thanks.
Thank you, sir. Participants can fill up the feedback link that has been posted in the chat box for session 2. After filling the feedback, you can leave.
Thank you very much.